Okay, so my solution is simply just that I will get this and this at the same time, and I will compare these two. If there are difference in these two, then I will return either -1 or 1, or else I will return, or else if this is the case, if this is the last revision, then I will return 0. But this is obviously not the last revision, right? There are tons of revisions remaining to be checked, so I will check these sequentially. So this, compare this with this, and then this with this, and then just things just go on. Okay, so in order to have like a clearer observation of my code, let's just jump right into our example. Okay, so with this case, with this input, these two input, okay, let's just, you know what, let's just make this. Okay, so the first thing we're gonna do is that we're gonna initialize these two variables as 0. So I1 stands for the index of version 1, and I2 stands for the index of version 2. So while true, so this is gonna happen, this is always gonna happen, right? So we will call the function revise here. Here, this is the function revise. We will give it two arguments, version 1 and I1. So this has two parameters here, version and index, as we expected. So this is the edge case that I'm gonna talk about later, so don't worry. So with this version 1, we will, okay, so version 1 here, we will give it I1, which is currently 0. So this is version 1 and index at 0. So S here, this S here is the string that is gonna be added this one into, and then we're gonna convert it into an integer. We will return it. Okay, so this while loop here, index is less than length of version. So if you're familiar with list or array or string traversing, this is typically easy, and I mean that's some basic knowledge of list traversing. And we want to guarantee that when we traverse, that we encounter this dot, we will stop and then we will return this. Okay, so that's why we have it here with, if the digit is not dot, we will continue traversing, but if the digit is the dot here, then we will stop. The while loop here. We will break out of the while loop and then just return the integer that we've found. Okay, so with version 1 here, as after this loop, it will become 0 0 and 1 0 here, and then we'll return the integer of s, and so it's 10 because we removed the leading zeros here. It's gonna be 10 eventually. So and with index, you can see here index stops at the dot. So index here is, I believe it's gonna be 4. So index is gonna be 4. So integer will return 10 and then 4 at its index. And with the version 2, we'll do the same as the version 1. We'll call revise version with the version 2 and I2 starting at 0. Okay, so this is just basically the same with version 1. The revision 0 of two versions are the same. So if the output of this function call right here, it's also going to be 10 and then 4, because it's basically the same, right? Yeah, it's the same. So right now we compare if revision 0 of version 1 is greater than revision 0 of version 2, then we will return 1, just as what the description says. We'll return 1 if revision 0 of version 2 is greater than revision 0 of version 1, and we'll return -1. So this is correct, basically what the description says, and we will circle back to this later, but right now we just not gonna care about this because it's the case where we return 0 if we scan through everything, like literally everything of the two versions, but we are just revised version which we have just revised revision 0 only. We have remaining revisions to check, so just don't care about this yet. And then we will increase I1 and I2 both by 1 because if you notice, after the revised function returns the index of these two, it stops at this index, right? So it stops right at the dot. But we want to move on to the next revision. We want to move on to revision 1, which is this. So we have to increase I1 and I2 both by 1 for it to be this digit and this digit, right? So we increase 1 and then move on to the second iteration of this while loop, which we will check revision 1 of both versions. Okay, so with this, let's just gonna be quick because I've reviewed this function already. So it's gonna output 1 and 1, removing the leading 0. So this will be 1 and 1, and I1. I mean, let's just not care about this. Let's just not pay attention to this because it's not really important anymore. Like if we see that 1 is the same as 1, right? So we haven't returned anything yet. That's right, we haven't returned anything yet. Okay, so this is the interesting part. We move on to our third iteration. Okay, so I1 now with our third iteration, I1 now is at this index right after the dot as we increased I1 by 1, right? But you see that version 2, we have nothing left to check, right? So this is where this logic comes into play, because this is again just some basic knowledge of list traversing. This is just to check if the index is out of bounds already or not. With version 2, we increase it by 1, so it obviously it's out of bounds already, right? So we're just gonna return 0, so the revision 2 of version 2 is 0, right? And it's the same, like if we just write it like dot 0 right here, it's the same, right? It's the same as this. So returning 0 is the correct approach in this. So we'll return 0. Both this and this will be 0, and it will not returning any of these because they are not different. They are the same again. They are both 0. And with this, so this is again some basic knowledge of list traversing, string traversing. If we see that both of these index are out of bounds, that means if we checked everything of these two, then we will return 0. If we haven't returned one of these two yet, right? If rev1 is not greater than rev2 and rev2 is not greater than rev1, then it can only be one case, that is rev1 is equal to rev2, adding the fact that we have checked everything in these two. So we will return 0 just as the description says. But not right now because we haven't checked anything. We still have two more revisions of version 1 to check, right? Okay, so coming to the fourth iteration, again, it's out of index already for I2, so we will return 0 So this is another representation of that. It's the same if we remove this. It's the same of adding this, right? So this revision versus this revision is gonna be 0, and then we will see that, okay, it's not this, it's not this, it's not this also, because we haven't checked the last revision of version 1 yet. We will increase to the 5th iteration of this loop. We see that we get rev1 equals to 1, right? Rev1 equals to 1, and then rev2 equals to 0, because as I've mentioned before, it's out of bounds. So the edge case is gonna be 0. So right now we found it. We finally found like the difference of these two versions. This one is 1, but this one is 0. So obviously rev1 here is 1, rev2 is 0. So rev1 is greater than rev1 is 1 greater than rev2, 0, 1 greater than 0. So we will return 1 at this point. Okay, so let's just run to check that if we did it right. Okay, so yeah, output expected 1, so perfect. And like the runtime of this algorithm is O of n, or maybe O of n plus m, right? Because we traverse through version 1 and version 2. So n is the length of version 1, we traverse through it, and m is the length of version 2, we also traverse through version 2. So, and the space, I don't know if the space is gonna be n plus m, because we used the space for this string, this s string, but it's not too much. And as you can see here, it's really efficient, 99.35%, 22 milliseconds, and the memory is also really efficient with more than 90%. And if you look at this, this is some kind of just slightly better than the solution that I've just shown you, but yeah, it's just slightly better, not substantial. But you can see that this solution is pretty, I mean, not pretty, really efficient, I must say. And that's all. Happy coding.